Okay, guys, we're going to look today at identifying a conic. And so what we're going to be given here, and I'm going to show you the first page, or one of the examples here, is really just a quadratic, and we're going to identify whether that is a parabola, a circle, an ellipse, or a hyperbola. So what I'm going to do is I'm going to give you a little shortcut here for all these, and they're really very identifiable in the standard form of these. So with parabolas, what you're going to notice is that one of the variables, like in the top one, the x is actually squared, and you're going to notice the y variable is not. And the same thing goes for this one. So you're going to notice that the y is being squared, but the x is not. So anytime that we have a parabola, you're going to find one of the variables is squared and one is linear. In other words, to the first degree, and squared technically would be quadratic to the second degree. When we see a circle, guys, you're going to see both the x is being squared and the y is being squared. But what you're going to notice is that, notice there's not a fraction here with these. You're going to notice that the numbers in front of your x squared, in front of your y squared, are going to be the same. So you're going to have, for this one, you're going to have an x squared and a y squared. Okay, but their coefficients are going to be the same. I'm going to tell you they're mainly going to be 1, but they could be both 9x squared and 9y squared. Not sure you're going to see that a lot, but it could. Now, a circle and ellipse, as you know, are pretty close to being the same thing. So that's what we're going to have here. We're going to have a x squared. We're going to have a y squared. Notice that they're going to be added together. They're both going to be positive, and they're going to have different numbers in front, okay, which is where the a squared and b squared really come from. So very similar to a circle, you're going to have an x squared and a y squared, but the coefficients are going to be different. They'll have different numbers in front of them. And the hyperbola, guys, is very similar to the ellipse. You're going to have an x squared and y squared. You're going to have different coefficients because you have those fractions. Let's see if I can write here. The only thing that's going to be different about this is this right here, guys. One of your variables, now whether it's your x, whether it's your y, doesn't matter, is that one of them will be negative, which gives us that subtraction there. Okay, so that is really how to identify these. And what we'll do is we're going to go through a couple of examples, and we're going to talk about all of this here and which one it is. And then we'll complete the square and just get them in standard form, which is going to be your directions. We're going to classify the conic, which is basically telling me what the conic is. And then we're going to write it in standard form, second part. So if I take a look at this, as I classify this, I have an x squared and a y squared. So I know it's not a parabola because parabolas, one of them is not going to be squared. One of them will be linear. So no, it's not a parabola. And then I look out front and notice I have the 9 and the 25. Those are different coefficients. So that makes me think it's an ellipse. But is one of them negative? Because if one of them was negative, I'll go back here, then I would know that it's now a hyperbola. Well, as I look at this, the 9 is positive, So is the 25. So I know right now that this is an ellipse. So let's just go ahead and get this in standard form like we did yesterday. So we're going to separate the x's and the y's. So let's take the x's here, 9x squared plus 36x. We'll separate the y's. So that's 25y squared. That is positive. Then the minus 150y. And then we'll go ahead and we are going to take that constant, and just like we did when we complete the square, we're going to move that to the other side. Now we're going to take these and we're going to, take these and we're going to put these into complete the square. So, which to get it in standard form is what we're going to do. So I'm going to factor out the 9 here. Leave my space like I have already. I'll go ahead and make that into a perfect square binomial because I know I just take half of that middle term. Okay, the 9's still out here. We know we square this, so that's a plus 4. And then we got to do distributive property, so 9 times 4 is a plus 36 goes out here. Okay, let's do our y's. Okay, so our y's, we're going to factor out the 25, and it's a positive 25 we're factoring out. So y squared minus, I think that's 6y. 25 times 6 is 150. 6 quarters makes $1.50. So the 25 stays out here. We'll complete the square here, so we know that's y minus 3. Okay, we square that 3, so we know 9 has to go in there. And then 25 times 9. Whew, that's kind of a big one. I think that's plus 225. I think 9 quarters is $2.25. As we go ahead, the negative 36 plus 36 cancels out pretty conveniently. Set equal to 225. Then to get this in standard form for an ellipse, guys, we're going to go ahead and we're going to divide everything by 225 to get this set equal to 1. And we'll do some simplifying here. 9 goes into 225. Oh gosh, I think that's 25 times, right? Okay, so this is going to be x plus 2 quantity squared over 25. And guys, I'm not sure why I did this, but let's take this squared off of here and let's put it outside our binomial like it belongs. A little mistake there. Then we're going to, 25 goes into 225, I think 9 times, pretty conveniently. So it's going to be plus y minus 3 quantity squared over 9. Then 225 over 225 we know is just 1 over 1, which is 1. So there's your standard form. Okay, here's our standard form for our equation. And we know it's an ellipse. So those are the two things we're looking for, is what kind of conic it is, and then we just put it in standard form, which means complete the squares. Okay, let's take a look at this one. Well, gosh, I have an x squared and a y squared, so I know it's not a parabola. As I look out in front, I notice that the numbers, the coefficients out front of my quadratics are both the same. And they're both positive, which tells me, hey, I'm pretty sure I know this is going to be a circle. Okay, so let's go ahead and get this in standard form for a circle. So we're going to separate the x's, separate the y's. We'll go ahead and take that 57 and move it to the other side because we're going to complete the square here. Oops. Let's complete the squares for the x. Nothing to factor here since there's no coefficient out front. So that'd be -3. So that's got to be what, a +9? So we're going to add 9 over here. For the y's, we'll do, that is plus y squared. So plus, this would be what, a y -8, half of 16, and then we got to add 64 here. Squared equals, gosh, guys, let me see, 57, well, let's see, 9 plus 64 is 73, and then -57 plus 73, I'm pretty sure that's 16. You might say, oh, it's got to equal to 1. Well, not for a circle, it doesn't. That's the radius squared there. So there's our standard form, and here's our classification. So it's a circle, and then here is the equation for it. Okay, guys, let's look at one more here. Well, once again, we've got an x squared and a y squared, so not a parabola again. I guarantee you, I'm pretty sure you're going to see a parabola here coming up soon. Notice we got different numbers, so that makes me think ellipse, except one of them is a negative. Okay, yes, it's a minus, but being a negative is the same thing. So as soon as I see that, boy, I know that's a hyperbola. So once again, guys, let's go ahead and separate. So we're going to separate the x's. We're going to separate the y's. And then we're going to take that 9, that constant, and move it over because we're completing the square here. Let's go ahead and complete the squares with the x's. So we're going to factor out that 9. Let's go ahead and complete that square. Half of that 2. And that would be a +1. Make sure you do your distributive here. So that's going to be a +9 over here. Let's do the y's now. Now, you look at that and you say, there's no number out front. Well, there kind of is. It's really a -1. So yes, I'm going to factor out a -1. You have to do that when it's a negative. So this is going to be y squared plus 6y. When I factor that -1 out of that -6, it's going to become a +6. Now let's go ahead and complete the square. And that'd be y plus 3, quantity squared. I'm going to square the 3, which would be a +9. Oh, well, that's going to be, oh gosh, I'm going to have to multiply the -1 times 9. So I'm actually going to subtract 9 here. And guys, this -1, you don't really need to write the 1 anymore. Just keep it as a negative. Let's go ahead and simplify what we have out here. So +9 plus 9 is 18. Then -9, so that's just a 9. And then go ahead and get it in standard form by dividing everything by 9. Get it equal to 1 for a hyperbola. That's what we have to do. 9 over 9 cancels, so it's just a 1. And I like to go ahead and write the 1 underneath here. I don't know if you have to, but I like to. And then this one, doesn't change. There's nothing to cancel out. So just a 9 on the denominator. And then 9 over 9 is 1. So there you go. There's standard form. And we know that's a hyperbola. Well, let's go. We got one more here, guys. I'm sorry. I thought maybe we were done, but we got one more here. And I'm pretty sure, well, look at this. I have an x squared and I have a, whoa. I don't have a y squared, do I? So, boy, When one of them's squared and the other one is not, I'm pretty sure, guys, that that is a parabola. So here's the first parabola we've seen. So let's go ahead and do some completing the square. Now, I do this a little bit different with a parabola. I like to have the squared terms to the right, and the linear terms to the left. If you take a look at how the standard form is back here, notice your squared terms are on the right side of the equal sign. On the left side are your linear variable. So that's what we're going to do here. We're going to first do some moving. So I'm going to subtract 4x squared over here. And I'm going to subtract this 16x. So I'm going to move the x's, the variables that are quadratic, excuse me, to the right side. And then over here, I'm going to have y plus 20. Yes, I'm going to leave that 20 there, because on the right side now is where I'm going to complete the square, which is what I have left when 0 minus 4x squared minus 16x. We're going to go ahead here, guys, and we're going to factor out the negative 4 to complete the square. So, guys, this becomes a positive 4x. Negative 4 times positive 4 gives me a negative 16. Okay. Then I'm going to go ahead and complete the square here. I know this is going to be x plus 2 quantity squared. Then, gosh, if it's plus 2, then up here it's got to be plus 4. I got to square that. And then negative 4 times positive 4 is a minus 16. And I have to take that and do that minus 16 to the other side. So over here, I get y plus 20 minus 16. That would be y plus 4. And then, guys, I'm done here. This is it. Only had to complete the square for one of them. So there's your parabola, and there is your standard form. Okay, guys, that's it. Okay, that's it for today. You got a worksheet that I will post here on the page, and I will also post these completed notes. Thanks.